211, what is this? The first thing I told you, let's overlook it for now, which is, where is it? Here it is. Sorry, 211, here it is. This is 211. Oh God, what does 211 mean? This 211, when it opens the path here, it will prevent the passage of the positive signals of the control function of the DS and IS from reaching the emergency, local and border remote. This means that any one of us, or all of us to be more precise, when any one of us operates the equipment, now all of us have this 211 activated. So when it activated, it opened the path here. And now the emergency, the local and remote paths are no longer operational. What does it mean that it's no longer operational? It means that now if we all go to the control circuit of the DS and AS and try to give a close command through the emergency or through the local remote, we won't be able to. Why? Because the DC coming through the emergency or the local remote has been cut off. Exactly, its path has been cut off. What path has been cut off? It's this contact. Is it clear like this, guys? So you have this contact with anyone who gives an operation command. What operation command does he have? As long as one of the cells is working with me. Clear. Very nice. Okay, what do we call this, guys? We call it, okay, I have prevented any, or what, it works. Okay. I also want to prevent the breakers from what? It works. Is that right? Okay. How do I get these breakers, or how do I prevent these breakers from operating? Remember when we were also working, and we will return to that later. Who is it who is sending? I will tell you in a few seconds, okay. You will find here there was a contact from the auxiliary, which is named K2111. If this contact operates, it prevents the negative from reaching the closing coil of the circuit breaker. And thus you won't be able to close the circuit breaker. For what? Is it clear, guys? So we now understand that K211 operates when any equipment in any other cell operates, which leads to K211C in the command panel being activated. Let's assume, for example, that it's the bus coupler that operates, activating K211 for me, or if I gave a close command to any equipment locally in my panel, in the local control, in the complete local control. All right, which is K211, what is that? So activating it means these two methods activate K211, which is supposed to prevent what? Prevent operation in my cells. So what does the problem say? I'll tell you what the problem is. What causes the issue? But honestly, my mouth is getting dry from talking. Okay, now I have a double pass here, and here's a knife switch here, and another knife switch here, and here's my circuit breaker, and there's another knife switch here. All right, good. Now, I've given the close command to this disconnector. Great. Let me give you an easy example. Now, I've given the close command to this disconnector, and this disconnector has closed. I came to give this in its way. And as it was closing, I came and said, what if it hasn't fully closed yet? It hasn't fully closed yet, meaning it's almost there. But there's still a gap. So I came and said, what will happen if this closes? An arc will occur on whose terminals? It will explode. Right. All right, so I gave a close command to this disconnector. And at the same time, I gave a close command to that disconnector. It was a quick action, like pressing close, or sitting at the computer and giving a close command to the close command immediately with one press. What happens is these two blades close together as if you have done what? You have coupled between the two bus bars, meaning you are passing current through it. I will also talk to you about its interlocking, but these two will explode. All right, let's say now you have the same situation with any other cells. So what did the West come up with regarding double operation? What is double operation? Simply put, they suggested implementing a rule to relieve us all from this issue. What does a rule to relieve us all mean? It means quite simply that as long as I am operating a certain piece of equipment, I should wait for it to finish its operation. This is so that, God forbid, if there is any voltage or any problem with the SF6 gas or anything else, it's resolved. Just stay with me first in this equipment, isolate it, and you can work on another equipment. So they created a general rule that you cannot give two commands in the same instance, just to the maximum extent possible. All right, and it also protects itself through what? Through interlocking, which is great. So this is the story of whom. The story is clear, right? Good. Now let's move on to the story of something called the long run time. What is this long run time, guys? The long run time, quite simply, tells you what? Let's focus together. Now, suppose you gave the disconnector switch a command. The disconnector moves, it moves, it moves. It is supposed to cover a distance or take its distance in about 3 to 5 seconds. All right? This disconnector is sitting 10 seconds, 20 seconds, 30 seconds. Wow. How long is it supposed to take in the first place? Yes, so they told you now, as I mentioned, that there is a disconnector, depending on the manufacturers, that takes, for example, 2 seconds, or 2.5 seconds, to say 3 seconds, 4 seconds. I haven't seen 5 seconds, but I'm telling you, like 5 seconds. He told you, it's simple. What will I do when I give a close command to any knife switch, any disconnector, any air switch? As soon as I give the close command, I will do the same action I used to do while supervising the charging time of the breaker's spring. I will activate a timer. The purpose of this timer is to start counting from the moment I give the close command to the disconnector or air switch. Ideally, if the disconnector or air switch completes its operation before the end of this time, then everything is fine. If it takes longer than this time, as soon as the timer finishes, it must give me an alarm and perform a specific action. All right, great. So the issue isn't about how it's done. It's not like a book. He went here and brought a timer. Okay, the timer named T2 is an on-delay timer. What does an on-delay timer mean? It means that when I supply it with power, it starts counting the time. And then after the time ends, it changes the state of its context. So how will this happen? This will happen quite simply, as I am now. I activated K31 and K32. Any one of them that operates will activate K31. What is K31? It's the one that brought the positive here and brought it down here. All right? It placed K21 in the path and K21 as well. K21 and K21 are also in the path. So if K21 operates, it will close this contact and also close this contact, right? And it's the one that activated K21. So, and it will also close. Who will it close? It will close this. Okay, very nice. So that means the DC will reach you. You might say to me, engineer, please don't trick us like that. Don't fool us. We believed you and trusted you, so don't deceive us. Why is it necessary? Where is it? You put it here and put it there again. It's not necessary. I mean, no. Why is it necessary? But I can't jump to a piece of information ahead that will confuse me. So consider with me now that kilometer 211, as soon as it started working, it closed here and closed here. Consider now the circuit drawn in front of you like this, okay? And so on, we would go to 11. What activates the word go to 11 is that it closes here. In the end, all this talk is about who will activate the timer. The timer is running, and if the disconnector switch is supposed to reach its final position, what should happen? If it reaches its final position, what happens is that FK21 should reset. If FK21 resets, it opens here. If it opens here, K2L1 will reset or drop off. So when it resets, the contact returns to normally open and the contact to normally open, and the power is cut off from the timer. And everything is fine and you have no problem, right? Okay, let's assume it continues to work normally, meaning that the switch, it didn't open at all, which means the disconnect hasn't reached the end of its journey. Okay, at that time, what would the situation be like after this timer ends? What is supposed to happen now? This means that the motor is either running idle, meaning there is no coupling between the rotor and its shaft bearing, and there is a problem, or the internal blade is broken. Something is wrong, right or wrong. So what is this timer supposed to do as soon as it finishes counting? You will find that as soon as this timer finishes counting, it will bring you here to this part, which is the motor circuit. It comes here in the motor circuit. Over there in the motor circuit of the breaker, what were we doing? Here we are. In the motor circuit of the breaker, when the timer finished counting, it would activate K13, and K13 would disconnect the circuit from K14 to cut the supply to which circuit? To the motor circuit. Here I will do something similar. what will I do? It comes here to this MCB, guys, which is the miniature circuit breaker. It is installed next to it mechanically, meaning that the miniature circuit breaker has something like a hole on its side, guys, an opening. All right, something called a small device is installed with this opening. It is something similar that is installed next to it and is connected to it through this hole. Okay, the part inside is like what we saw in the switch, a coil with an arm. So as soon as you apply voltage to this coil, it pulls the arm, causing it to drop or disconnect. What does it disconnect? All right, so the trip unit, which is called C1 and C2, you'll find that C1 is taking the positive from this rail here, taking the positive here, and taking the negative from the other rail, which is 1, taking the negative from the other rail. But this connection is interrupted by a switch. So this means that as soon as you close the miniature circuit breaker, once you close here and here, it receives the positive from above to get the negative. This happens if the timer finishes counting. As soon as the timer finishes counting, the negative comes here directly to the C2. So as soon as this trip unit operates, do you see this line? What is this line called? This line is called the mechanical interlock. Of course, there is mechanical coupling between this shunt coil and the MCB, which pulls the MCB to do what? It trips the MCB. So this is the story of the long run time. The long run time here is for the disconnector and earthing switches. Its purpose here is to disconnect the motor circuit, to cut off the supply to the motor circuit, and to stop all the motors from operating. All right, as I continue in this part, someone might come and ask me, why did you use KIM 211 here again? Yes, let me tell you. Now, when I activated KIM 211, didn't it close here? KIM 211 either closed or operated, meaning KIM 211 was activated, right? So when KIM 211 closed, it closed here and activated KIM 211. So KIM 2211 closed here, and because KIM 2211 was already operating here, it connected the supply, right? Am I wrong? This is correct, depending on when I gave the close command to the disconnector switch in my panel, right? I told you, right? Now, Engineer Fad, you're asking me, okay, I'm just telling you, now I'm just saying, suppose there's someone in the adjacent cell, consider that you now gave the close command to your switch. So your switch, you have KIM 211 operating, which went to the bus bar before you and activated KIM 211 over there. Now, in my panel, the contact tripped because there was equipment operating in one of the other cells. If I hadn't placed these here, what would have happened? This supply would have passed through here to the timer, and you have a timer. So you have a switch operating in your panel, and a relay in your panel activates my timer and disconnects the motor circuit from my line. And what fault is it of mine? I don't have a problem. The problem is on your side. That's why in this path, I had to place a contactor called GAM, which is KIM 211. Why? Because many times 111 EDA doesn't work when the operation command is for one of my equipment. What? For one of my equipment. Is that clear? All right, great, I am. So this is the story of what? Double operation, long range, time. Let's talk about 211. Is it necessary? No, it's not necessary. It's perfectly fine if you don't include it. There are no issues at all. All right, great, I am. But what's important for you is what? You have the time. I'm not forgetting it. As soon as the timer works properly, turn on the timer, which is FCAM, F52. So F52 has disconnected the supply port from the A circuit and the motor circuit, right? The MCB itself has disconnected the supply from the A circuit and the motor circuit. So I have protected my motors and ensured the long run time. Okay? Long time. Great. Great. So now I understand the double operation and the long run time, and we've understood the motor circuit. We had left this part and now we've closed it. Now let's move on to the DS. And DS control circuit. The first thing we saw here is K211. We said that when I give a close command to anything, to any command I have, or any command present in JS, in the end, I have an auxiliary layer called K211. It will come to me from the panel, but before the common panel, to activate K211. If I want to give a close command to any comment or task I have, I will also activate K211. K211 will disconnect the supply from my control circuits, which are the emergency, local, and remote circuits responsible for giving the close or open command to any DS and ES. At the same time, we used K211 to disconnect the negative in the circuit breaker circuit so that I cannot give a close command to anyone. For the circuit breaker, clear and nice. Okay, someone might ask me, well, why did you disconnect the emergency, local, and remote with it and not the direct DC? I'll tell you, it's very simple. First, if I disconnected the direct DC from the beginning here, I would have disconnected all the DC, which would cause several problems. The first problem is that this DC goes to page 9, which is this page, which actually contains the double operation activation, right or wrong. So the double operation was functioning because there was DC on this page. When you disconnect the DC from it, the double operation won't work. The long runtime isn't working, right or wrong, right? That's number one. Number two, if you disconnected the direct DC, when you gave the select close here and activated K21, didn't K21 latch onto itself? Right, why? Because as soon as you remove your hand from the command, whether from emergency, local, or remote, it only sends a pulse from the PCU. In the end, K21 will be reset, which is why it latches onto itself until the switch reaches the end of its journey. So K21 latches onto itself, but it definitely won't latch from emergency, local, or remote. It latches onto itself from the direct, specifically from the direct DC, my explicit positive. So if I cut the explicit positive, it means that there won't be any latching and all operations will be incorrect. All right then, guys, very good. So what do you have? You have the idea that K21.1 only cuts the control path so that you don't give a new command. However, the new command you have remains present, plus it is already running the double operation circuit. What is your long run? It's your long run time. Great, guys, very nice. Now, there's also a very important piece of information here. What is it? If you now enter your cell panel or bay and close the MCB of the control circuit, which is F71, it doesn't make sense to then give a cruise command to the disconnector when you haven't even turned on the MCB or activated the MCB that powers the motors of the disconnector and the air switches. That's why you'll find that even if you turn on the MCB that powers the control circuit of the DS and the ES, even if you have it turned on, the supply will reach below. And before it goes to this circuit, it will find that it is disconnected by an MCB called F52. This isn't an MCB, meaning here's its symbol. What is this? It's a normally open contact from the MCB. Now, which MCB is this normally open contact from? It's from MCB number 52, which powers the motors of the disconnector and the earth switches. That's why the supply cannot go down to the control circuit of the disconnector and the earth switch without having the MCB that powers the motor circuits of the disconnector and the earth switch turned on. As soon as you turn it on here, the supply will come down and power your circuit. However, in the case of a long run time, as we saw earlier, the trip relay will activate and open the MCB F52. Once it opens, I have taken a normally open contact from it and at the same time a normally closed contact. Of course, the terms normally open and normally closed refer to the MCB, which is originally depicted in the open position, right? So now let's say the MCB was closed. So this is closed, right? And this is open. If a trip occurs to this MCB due to the long run time, the status of your contacts will be as you see in front of you. So at that time, this is originally closed. All right. So at that time, what will happen is it will come from here, pass through here, and go to whom? On 2 and 7. And the negative will come from here and go to K2 and K7. What does K2 and K7 do if it works? It gives you it informs you by God that now with the circuit of the motors is what people are discouraged. Let's play. It has now become soil, meaning it is now open as a result of changing the color of the ring.